My name is Eline Lauwers. I'm clinical project manager at Fluida. And before I started working here, I did a PhD at the University of Antwerp. And the research I will be presenting here today is still results that I gathered during my years at the university. And during my PhD, I focused on two novel outcome measures for cystic fibrosis. On the one hand, we looked at functional respiratory imaging with Fluida, but a big part of my PhD was also about digital lung sounds. And the study here is to explore to what extent these novel digital lung sound characteristics, for which we used a novel analysis, to what extent those characteristics are related to imaging biomarkers, functional as well as structural imaging biomarkers. So we performed lung sound recordings at different chest locations in cystic fibrosis patients, and on the same day we performed the CT scans, which were afterwards analyzed with a more conventional method, the CFCT scoring method, and then also the FRI analysis was performed. And then for the results, we saw multiple significant associations between the structural abnormalities that were seen on the CFCT scoring method, but we also saw some important relations with the structural abnormalities seen on FRI, and also area resistance as one of the functional parameters in FRI. So these results indicated that we can use this novel automated approach to analyze these lung sounds as a new outcome measure for cystic fibrosis. And the idea is that we don't really want to replace imaging, for example, as an outcome measure, but the good thing about digital lung sounds is that it can complement regional information from imaging, because this type of analysis or this type of measurements we can do more on a frequent basis, and it's more easily accessible at different sites.